This video is about probabilities using Microsoft Excel. I will discuss these topics: discrete versus continuous variable, custom discrete probability, binomial probability, Poisson uniform distribution, and standard normal distribution. Discrete variable may assume only certain values. Continuous variable, on the other hand, can assume an infinity number of values. For example, number of students in a classroom. There can be 20 students, 21 or 22 students, but there cannot be 20.5 students. Number of bedrooms in a home. There can be 2 or 3 or 4 bedrooms, but there cannot be 3.5. Similarly, number of kittens can be 3, 4 or 5, but there can never be 3.5 kittens. They are represented by whole numbers. Continuous variables, on the other hand, can take any value within a given range. For example, height could be 72 inches. It could be 73 inches. It could also be 72.5 inches. Temperature could be 90 Fahrenheit, 91 Fahrenheit. It could also be 90.1, 90.5 and 90.7 Fahrenheit. Same is the case with weight. For discrete variable, these are probabilities: custom discrete probability, binomial and Poisson. And for continuous variables, these are probabilities: uniform distribution and normal distribution. For custom discrete probability, we use relative frequency, the probability distribution that's generated from observations, and the possible values of the random variable are finite and only certain clearly separated values can be assumed. They are represented by a relative frequency table. Few examples are number of cars sold per day or number of credit cards by customer. Here's an example of custom discrete probability. First of all, as you can see that these variables are discrete, which mean number of cars sold. You can sell 1 car, 2 car, 3 car, but you can never sell 3.5 cars. In this data, you have no cars sold on 54 days. 1 car was sold on 117 days, 2 cars were sold on 72 days, and we have this data for 300 days. If you want to calculate probability, our first step is to take the percentage of each. So I will divide each of these values by the total. So 54 divided by 300, that will be 0.18. 117 divided by 300, that will be 0.39. 72 divided by 300, and in this way we'll keep doing. So that gives us probability. So the probability that 0 cars would be sold is 18%, probability that 1 car would be sold is 39%, probability that 2 cars would be sold is 24%, and then here is probability of 3, 4 and 5. And as you can see that all these probabilities, they sum up to 1 or 100%. Now if we want to calculate expected value, for expected value, our calculation would be, we'll multiply x and fx. So this is our x and this is our fx, that's probability. 0.18 multiplied by 0, that's 0. 0.39 multiplied by 1, that will be 0.39. And in this way, when we multiply all these values, we take the sum. And the sum of all these values is 1.5, which represents the average or a long-term average that you can expect 1.5 cars would be sold. We can also do it using Microsoft Excel. So for example, in Microsoft Excel, we have this data, which is sales volume and the number of days. So here, for example, we have this data. I will divide the frequency by total. So which means 54 divided by total, which is 300, and I will log it by pressing F1 and F4, because in the next step, I'm going to drag it down. So if I drag it down, it gives us probability of each. And then in the next step, we'll multiply x and fx. So this is our x and this is our fx. So 0 multiplied by fx. And if I copy this formula to the lower cells, we have this one. And then if you take the sum of all these, that gives us 1.5, which is the probability that 1.5 cars would be sold. So that's a long-term average. The next one is binomial probability. Binomial probability is also about discrete variable. For example, if you flip a coin 10 times and you are interested in determining the probability that there will be 6 heads or 6 tails when you flip it 10 times. So that type of probability is called as binomial probability. And for binomial probability, there are 4 conditions that must be met. So the first condition is that the experiment consists of a sequence of n identical trials. So when you flip a coin 10 times, that will be 10 trials. Second, 2 outcomes are possible. Either it could be head or it could be tail. Third condition is that the probabilities of the 2 outcomes do not change from one trial to the next. So if you flip a coin 1 time, probability will be 50% of either head or tail. If you flip it second time, probability remains the same. That doesn't change. If you flip it third time, fourth time, and fifth time, probability remains the same. And the last condition is that all these trials are independent, which means one trial is not affecting another one. So when you flip a coin first time, that's an independent trial. When you flip it second time, the first one is not affecting the second one, and the second one is not affecting third one. So these are 4 conditions that must be met. We will do binomial probability in Microsoft Excel. We'll be using this formula, which is binom.dist, which is a contraction of binomial distribution. And then when you write parentheses, it gives this pop-up suggestion, and it says that these inputs are required. So the first one is, as you can see here, number of outcomes. The second one is trial, the total number of trials, how many experiments are there, and probability. And the last one is cumulative. So for example, in this case, in the example of flipping a coin, and you are interested in determining the probability of having 6 heads or 6 tails, 6 will be number. And because you are flipping it 10 times, so the value of trial will be 10. And probability in this case will be 50%, because we know the probability of getting a head or tail is 50%. And for cumulative, it requires input as either false or true. So you need to mention one of these, false or true. So whenever you are going to determine the probability of a specific number, for example, you want to determine the probability of 6 heads or 6 tails, in that case you will mention here false. However, if you want to calculate probability of 0 plus 1 plus 2 plus 3 plus 4 plus 5 and plus 6, that will be cumulative, and for that you will enter true. For example, n is equal to 2. If you want to calculate the probability of 2, exactly 2. So here is 2, and in this case you must enter here false. If you want to calculate the probability of 0 plus 1 and plus 2, that will be cumulative probability, and for that you will mention here true. And on the other hand, if you want to calculate the probability on this side, on the right tail, that will be 1 minus cumulative, because this whole total is equal to 1, and 1 minus cumulative, that will give the probability from this point to this point. Let's solve one problem using Microsoft Excel. So here we have one problem, and the problem says a survey on British social attitudes asked respondents if they had ever boycotted goods for ethical reason. The survey found that 23% of the respondents have boycotted goods for ethical reason. This problem perfectly fits the framework of binomial probability, because first of all, there are multiple trials, which mean multiple respondents, and all these respondents are independent. And second thing is that they are not influencing each other. And probability that they will boycott something, that is 23%, that remains the same. In a sample of 6 British citizens, which means that's our total number of trials, what's the probability that 2 have ever boycotted goods for ethical reasons? So 2 is the value of x, and the total number of trials will be 6. So for example, over here, the first question is that if the value of x is 2 and n is 6, n is the total number of trial, and for this one I'll be using this command binom.dist, and then as you can see in the pop-up, it's asking input number. Trial we know is 6, and then probability is highlighted, and we know probability is 0.23 or 23%. And the last thing is cumulative, because in this case we are interested specifically in calculating the probability of only 2, so it will be false. We are not calculating cumulative probability. And if I hit enter, that gives us probability of 0.2789. You can also convert it into percentage by clicking on this one. Let me do this part first, which is calculating the probability that no one has ever. So here's the question. In a sample of 10 British citizens, now over here the number of trials has increased to 10. Initially it was 6, but now it's 10. What's the probability that none have boycotted goods for ethical reason? So the value of n is 10 and the value of x is 0. None means 0 because we are interested specifically in calculating the probability of 0. Therefore, for cumulative, our input will be false and our formula will be binom dot dist, and then first is number is, we know, 0, trial is 10, and then probability is 23%, and then false because we are interested in calculating only the probability of 0. If I hit enter, that gives us this one, 0.0733. If you wish, you can convert it into percentage, so which means almost 7%. In a sample of 6 British citizens, what's the probability that at least 2 respondents, so at least 2 mean that 2 and more than 2. We have two options. One approach would be to calculate the probability of 2 plus 3 plus 4 plus 5 and so on. But a better approach is that total probability is 1 by calculating the probability of 0 and 1 occurrence and then subtracting both from total probability of 1. That will give us the probability of at least 2. So my formula will be 1 minus binom dot dist 1. Number of trials is 6, probability is 0.23, and cumulative will be true because in this case I want to calculate probability of 1 and 0, and then it will be subtracted from 1, and that will give us the probability of 2 and more than 2. So when I hit enter, it gives us the probability of greater than 2, which is 41.8%. The next probability for discrete variable is Poisson probability. It's concerned with number of occurrences over an interval, and that interval could be time or length. Some examples are number of patients who arrive at a healthcare clinic in 1 hour. So that 1 hour is the time interval and number of patients is occurrences. Number of computer server failures, that's occurrence in a 1 month. So that is the time frame or interval. Number of repairs needed in 10 miles of highway. Potholes on the road, these are occurrences in a specific interval, and number of leaks in 100 miles of pipeline. So that is interval and number of leaks is occurrences. And we want to calculate the probability of these occurrences. We will be doing it using Microsoft Excel, and the formula will be this one is equal to Poisson.dist, which means distribution, and when you enter here open parentheses, it gives suggestions. So as you can see, the suggestion will be X, which means the number of occurrences we are interested, and then mean, and then cumulative. And here is an example. It says the website of a company averages approximately 7 visitors per minute. Now, as you can see, this sentence, it perfectly describes or meets the conditions of Poisson probability. In Poisson probability, we have a time interval, and time interval is minute per minute. And in 1 minute, the number of occurrences is customers who are visiting that website, and that's 7 visitors. And the question is, what's the probability of no website visitor in a 1 minute period, which means we are interested in the probability of 0, x is 0, in 1 minute period. And the formula used for this purpose is this one, which means is equal to Poisson.dist. And when you type parentheses in the pop-up, it asks the first input is x. So we know in the first question we are interested in finding the probability of 0, and then mean we know is 7. That has been given here in the question, that's 7 visitors per minute. It will be 7. And then the question is cumulative or false, because we are interested in determining only the probability of 0, nothing less, nothing more. So therefore it will be false. And if I hit enter, that gives us this probability. You can also convert it into percentage. The next question is, what's the probability of 2 or more website visitors in a 1 minute period? Now 2 or more website visitors, which means it could be 2, 3, 4, 5, 6. For this one, we'll be using the same approach. We have two options. One thing is that we calculate the probability of 2 plus probability of 3 plus 4 plus 5 plus 6, and we don't know where it goes. So the best approach will be we calculate the probability of 1 and we subtract it from 1. So we know that the total probability is 1, and if from 1 we subtract the probability of 0 and 1, that will give the probability of 2 and everything above 2. 2, 3, 4, 5, 6, whatever it is. So I'll be using this approach. I will write 1 minus Poisson distribution and then I will calculate 1, mean value is 7, and then I will write here true. I'm writing here true because that will give me the probability of 1 and 0, which I want to subtract from 1. So if I hit enter, that will give us this probability, that's 99.27%. And as you can see in this approach, we have one occurrence, and because we are using true, which means this part, this highlighted part will give us the probability of 0 and 1 because it's cumulative probability. And once we have the probability of 0 and 1, we subtract it from 1, that will give us the probability of everything except 0 and 1. In other words, that would give us the probability of 2, 3, 4, 5, and 6 and everything at least 2. Which is exactly this question, the probability of 2 or more website visitors. Now the third question is, what's the probability of 1 or more website visitors in a 30-second period? In our original statement, lambda, which is also called as mean, so here as you can see mean or lambda, that was 7. This is given in the question in the top statement. There are 7 visitors per minute, but over here time frame changes and it's talking about 30 seconds. So in 30 seconds there must be 3.5 visitors. So we will change lambda accordingly because our time frame has changed from 1 minute to 30 seconds. So we will also change our mean or lambda. So for 1 minute it was 7 visitors, for half minute or 30 seconds it must be 3.5. So I'll be using 3.5 as mean for this question only. And the question is that what's the probability of 1 or more website visitors, so which means greater than 1. I will calculate the probability of 0 and then I will subtract it from 1. So 1 minus boson and 0, and then 3.5 is our new average. And then it doesn't make any difference if you write here false or true because it's 0. 0 is already at the bottom. So that gives us this probability that's 96.98%. Again, as you can see that this highlighted part gives us the probability of 0. And when we subtract it from 1, that gives us the probability of everything except 0, which means probability of 1, 2, 3, 4, 5, 6, whatever it is. And that's exactly what the question is about, the probability of 1 or greater than 1. The next type of probability is about continuous variable. Continuous numbers can take infinity number of values. For example, as I was giving example about temperature can be 92 Fahrenheit, it could be 93 Fahrenheit, but it could also be 92.5, it could also be 92.7. So that's why it's called as continuous variable. And for continuous variable, we have these two probabilities, uniform distribution and standard normal distribution. Uniform distribution, it's a type of probability that's defined by a minimum and maximum value. These type of questions will always have minimum and maximum value, and our interest is to determine the values in a range. So for example, flights arrival time within a range, buses arriving at a bus stop, lifetime of a bulb within a range. So range is the key word in this one. And this type of probability will be in the shape of a rectangle. So in this case, the minimum value is 2 and the maximum value is 8. The difference here, or the length of this part, is 6. 8 minus 2 is 6. And height will be inverse of this base. So if this is 6, this should be 1 over 6. So I'll be using this approach, that area is equal to base times height. The base is 6 and height is 1 over 6. So the total area will be 1. The probability will be 1 or 100%. Here is an example of uniform distribution probability. Regarding a bus service on campus, students arrive at the bus stop at random times. The time that a student waits is uniformly distributed from 0 to 30 minutes. We have been given a range. Draw a graph of this distribution from 0 to 30, that's a base, and the height, that's inverse of this base. So if this is 30, height will be 1 over 30, or in other word 0.033. And when we multiply that, 30 multiplied by 1 over 30, so that gives us 1. So that gives us answer to first these two questions. Draw a graph of the distribution. This is a graph of the distribution. And the area, this total area, orange color area, is 1. And the next question is, what's the mean of this distribution? And the mean of this distribution is the mean of this one, 0 plus 30 divided by 2. So here we go. 0 plus 30 divided by 2 is 15. So 15 is the mean. Then the next question is, what's the probability that a student will wait more than 25 minutes? So here is 25 minutes. So the question is, what's the probability that a student will wait more than 25? We have to calculate the area of this orange rectangle. This is 25, this is 30, so which means this base is 5. And if this base is 5, we already know the height, this one is 0.033. So if we multiply 5 by 0.033, that will give us the area of this orange color rectangle. So 5 multiplied by 0.033 is equal to 0.1667. So that is the probability that a student will have to wait more than 25 minutes. Let's do this in Microsoft Excel. Shuttle time is uniformly distributed from 0 to 30 minutes. What is the mean waiting time? So mean waiting time is just the average of minimum values 0 and 30, that's 15. The next question is, what's the probability that a student will wait more than 25 minutes? So this one, 25. I'm using here this formula whereby minimum value in the range and maximum value in the range and minimum value of interest and maximum value of interest. So we know that our minimum is 0, as you can see here 0, and maximum value is 30, that's a maximum, and the minimum value of our interest, in this case we want to calculate the probability that it will take more than 25 minutes. So our minimum value will be 25 and the maximum value will be 30. So as you can see here, 30. And I'm using this formula, that's maximum value of interest minus minimum value of interest divided by the difference of maximum value in range and minimum value of range. And that will give us 16.67. And the last one, what's the probability that a student will wait between 10 and 20 minutes? First we draw it here. We know this is 10 and this is 20, so which means we are interested in calculating the probability or area of this orange color rectangle, and we know that this is 10 and this is 20, so which means this base is 10 and 10 multiplied by height is 0.033, so which means this probability or the area will be 0.333. We can also use this calculation. Minimum value in the range, that's 0, and the maximum is 30. Now we talk about minimum value of interest, that is 10, and maximum value is 20. Here as you can see, this is 10 and 20, and again I'm using the same formula, and that gives us this probability, which is 0.33. We can also convert it into percentage, that will be this much, 33.33%. Here is another example of uniform distribution. Rainfall in an area follows a uniform distribution between 0.5 and 3. Now that is the range that has been given, that's our starting point. What is the mean amount of rainfall? And we know mean is the average of these two, which means 0.5 plus 3 divided by 2. So 3 plus 0.5 will be 3.5. 3.5 divided by 2, that should be the mean. So here we can see minimum value was 0.5, maximum value is 3, and if we take the average, as you can see, the average of these two, that is 1.75. Then the next question is, what's the probability of exactly 1 inch of rain? Now this is one property of uniform distribution, because this is about ranges. Whenever we are asked to calculate the probability of one specific value, that will be 0. For example, in this case, what's the probability of exactly 1 inch? That would be 0, because we are concerned with ranges and that's not the range. So this is one property of uniform distribution. And the last question is, what's the probability of more than 1.5 inches of rain for the month? Suppose if I say 1.5 turns out to be here, because it's more than 1.5, so which means we are supposed to calculate this area. So if we could calculate this area, that will be the probability that there will be more than 1.5 inches of rainfall. And for that purpose, we can use this template whereby our minimum in the range, we know that's 0.5, maximum is 3, that's a 1, that's given 0.5 and 3, and then these are the values of our interest. Our interest is in 1.5, that's 1.5, and the maximum is 3. If we use this formula, that gives us probability of 60%. So which means the area of this one is 60% or 0.6. The last one is standard normal distribution. Standard normal distribution is a very common type of probability that's used. If you take a sample, a very large sample of anything, for example, weight of people, height of people, GP of people, their SAT score, and if you draw it, it's likely to give this type of distribution whereby some values on this side, which means some extreme values, the values that are very low, they will be here. Some values that will be very large, they will be here. Again, they will be relatively small, but most of the values here somewhere in the middle. So this is called as bell curve distribution. And this is about standard distribution. Here we say that this is standard deviation here is 0 because this is mean, and one standard deviation here and one standard deviation here. The amount of data that falls here, that will be 68%. So 34% here and 34% on this side, that will be 68%. And then from here, that is 2 standard deviation here and 2 standard deviation here, that will be 95%. And then practically all data falls here. This is also called as empirical rule. We will be calculating standard normal distribution using Microsoft Excel. The step is that make a bell curve to make sense of the problem, add information into the bell curve including mean, probability or x value. This command, that's norm.dist, and then it will require these type of inputs: the value of x, mean, standard deviation and cumulative. And for cumulative we'll be using the same logic. So here we have a problem, and the problem says in 2003 the average stock price for companies making up S&P 500 was $30. So that's one piece of information, that their mean price was 30. So I will write it here. And then it says standard deviation was 8.2. So I will also write here standard deviation is 8.2. And then the question is, what's the probability that a company will have a stock price of at least 40, which means 40 or more than 40. It could be 41, 42, 43, anything. And therefore, our question will be, what's the probability that x is greater than 40? So that's something that we have to calculate. I will use this formula, norm.dist, which is a contraction of normal distribution, and you can see here it's asking input x. What's the value of x? And we know x is 40. We are solving the first part where it says 40, and then it says what's the mean. As you can see, mean is highlighted. We know mean is 30 from this top cell. Standard deviation is 8.2. I will enter it true and I will explain it. So for example, this is the bell curve of this problem, and in this bell curve we have this 40, and the question is, what's the probability that the stock price will be higher? So in other words, we have to calculate the probability of this green area, and we know that the total area under the curve is 1, and we have to calculate the area of this green color. So for this purpose, this command will give me cumulative probability of the lower tail, which means everything less than 40. And then I know that the total probability or the total area is 1, and I will subtract that probability from 1, and that will give me the probability of this area, and that gives us 88.86%. So which means this area, this white area, is 88.86%, but we are interested in the area of this green one, so we will subtract that from 1, and which will be 1 minus this one. This is the probability, and this represents this green area. So this green area represents a probability of 11.13%, which means the probability that the stock price will be higher than 40 will be 11.13%. The next question is, what's the probability that a company will have a stock price no higher than 20? The figure will be like this one. This is our bell curve and this is 20. It says no higher than 20, which means less than 20. So what's the probability that this will be the stock price? Norm.dist, and x is 20, mean is 30, standard deviation is 8.2, and cumulative is true. And that gives us probability of 0.1113. In other words, it's 11.13%. We can convert it into percentage. And the last one is, how high does the stock price have to be to put a company in the top 10%? Now this top 10% is about probability. This $40, that was the value of x. this $20 is also the value of X, and this 10% is not the value of X, but its probability. So top 10% mean it would be like this one. So what would be the value of that stock, which means we have to calculate the value of X to put the company in top 10%. Total area under the curve is 100% or 1. So if this is 10, then all other one must be 90% or 0.9. But in this case, I will be using slightly different command, because we are not going to calculate probability, but rather we are going to calculate the value of X. So that command will be norm INV, and then it says probability. So probability, we know it's 90% or 0.9, and then mean, that's 30, and then standard deviation is 8.2, and that gives us 40.5. It means that if a company has to be put in the top 10%, its stock price should be this one, 40.5. One more example, General Hospital's patient account division has compiled data on the age of accounts receivable. The data collected indicates that the age of accounts follows a normal distribution, with mean is 28 days and standard deviation is 8. Standard deviation is sigma. We have been provided mean and standard deviation. What portion of accounts is between 20 and 40 days old, which means more than 20 and less than 40? So here is our data. Mean is 28, standard deviation is 8, and what we have to figure out is 20 to 40. So here is the figure. Mean is 28, and this is 20, and this is 40, and we have to calculate this area, the area that's represented by brown arrow. Now the question is how we are going to calculate this area, and for that purpose I will use a two-step approach. The first one is I will calculate the cumulative probability by using 40. So which means that will give me the probability of everything less than 40. So starting from this extreme to everything up till 40. And then in the next step, I will calculate the cumulative probability of 20, which means that will give me the probability of everything less than 20, and then I will subtract this one from the cumulative probability of 40, and that will give me this area. So here, for example, if we want to calculate the probability of less than 40, our approach will be norm dot dist, and then X is 40, mean is 28, and standard deviation is 8, and cumulative true. Yes, we are calculating cumulative probability because we want to calculate less than 40, everything that's less than 40. So if I hit enter, that gives us 93.32%. Then I want to calculate what's the probability of less than 20, and for that it will be norm dot dist, and value of X will be 20, mean will be 28, standard deviation is also 8, and cumulative is true because again I want to calculate the probability of 20 and less than 20, and that's 15.87%. Now in the next step, I will subtract this one from this one, and that will give me the probability of 20 to 40%. So 93.32% minus 15.87%, and that gives us 77.45, which means the probability of this area between 20 and 40 is 77.45. The next question is, the hospital administrator is interested in sending reminder letters to the oldest 15% account. Now this oldest 15%, again the thing is that this is probability, this is not the value of X. This was the value of X, 20 is the value of X, 40 is the value of X. But this is percentage, that's probability. So oldest 15% account, where they would be? They would be here because they have the highest value here. And we know if this is 15, then this must be 85% because the total area under the curve is 100% or 1. So 85% plus 15 is equal to 1. Then the question is that how many days old should an account be before a reminder letter is sent? So in other words, what should be the number of days here? If it qualifies to fall in oldest 15%, or this one we can use norm INV formula, because in this case we have been given probability. We are not going to calculate probability because probability is already given. So that will be norm INV, and as you can see it says probability we know it's 0.85 because that's the cumulative probability, and mean is 28, and then standard deviation is 8. So this value is 36.29, or we can round it off to 37, which means any account that's either 37 days old or more than that should be sent reminders for payment. And the last question is, the hospital administrator wants to give a discount to those accounts that pay their balance by the 21st day. What percentage of the accounts will receive discount? We will make a figure, and as you can see in this figure, this is the figure. By 21st days they will be given some discount. Accountant wants to know how many customers would be entitled for discount, which means what is their percentage. So we are interested in calculating this green area. In this case we have to calculate probability, so we'll be using this norm dist formula, and that will be is equal to norm dist. And as you can see, the first thing is x will be 21, and then mean we know that's 28, and then standard deviation is 8, cumulative true, and that gives 19.1%. So which means if the hospital administrator wants to give discount to those people who pay their bills by 21st, they will be 19%. So 19% representing this green area will qualify for a discount. One more example, fast service truck lines use the Ford Super Duty F750 exclusively. Management made a study of the maintenance cost and determined the number of miles traveled during the year followed the normal distribution. The mean of the distribution was 60,000 miles, so that's one input, and the standard deviation was 2,000 miles. And the question is, what percent of the Ford Super Duty F750 logged 65,200 miles or more? So that is one, this is the value of x, which means we have to calculate the probability of traveling 65,200 or more miles. And this is our data. That mean is 60,000, standard deviation is 2,000, and the first part of the question is what's the probability of 65,200 or more, because we have to calculate probability. So I'll be using norm.dist, and the first one is x, which is 65,200, and then mean we know is 60,000, and then standard deviation we know that's 2000, and cumulative, yes, we need cumulative. This gives us cumulative probability, which means less than 65,200. So for example, in this figure, if this is 65,200, we know this is mean. In the center, that's 60,000, so this is 65,200, and by cumulative we mean that it gives us the area on the left of this red color line, which means all this area starting from this tail up to this red line, all this area is 99.53%. But that's not our question. Our question is what's the probability of greater than that, which means we are interested in this red area, in this area on the right side where you can find this question mark. So for that purpose, we know that the total probability is 1, the total area under the curve is 1, so we will subtract this one from 1. So which means I can just enter here 1 minus, and I will add here a few parentheses which are necessary, and if I hit enter, that gives us 0.47, which means this area is 0.47%. So the probability that a Ford truck will log more than 65,200 miles is 0.47%. The next part of the question is what percent of trucks logged more than 57,060 but less than 58,200 miles. So that becomes our data. These values are less than the mean because we know mean is 60,000, so which means they are here somewhere. So suppose 57,060 is this line and 58,280 is this line. And the question is asking what's the area between, which means greater than this one but less than this one. So we are interested in calculating this area where you can find this green color question mark. So for this purpose, I will be calculating first the cumulative probability of this one, which means 58,280. So that will give me the total probability of everything left to this line, which means everything including here. In the second step, I will be calculating cumulative probability using this value, which means 57,060, and that will give me probability of everything to the left of this green line, and then I will subtract these two, or in other words, the area of between these two green lines. I will use this formula, that's norm dot dist, which means normal distribution, and then x, which we know is 57,060, and then mean, which we know is 60,000, and standard deviation, as you can see it's highlighted, is 2,000, and cumulative, we know it is true because we want to calculate the probability of everything on the left of this green line. That gives us 7.08%. So this gives us the probability of area to the left of this green line, which means starting from here up to this extreme end. In the next step, I will calculate cumulative probability using 58,280, which represents this green line. So that will be norm dist, and then x, value of x is 58,280, and mean is 60,000, and standard deviation is 2,000, and true, which means yes, we want to do this one. So that is 19.49%, which means the area to the left of this green line, the whole area starting from here to this green line, is 19.49%. Now we have this area, that's 7.08, which represents this area, and we have this total area. If we subtract 7.08 from 19.49, that will give this area that's between these two green lines. So that will be 19.49 minus 7.08. It shows that this area between these two green lines is 12.41%, which means this is the number of trucks that logged more than 57,060 miles but less than 58,280 miles.